is the climate changing faster than the trees can respond? Will climate change cause succession to a different set of tree species than we already have in Minnesota? Will it cause the forest to be replaced by prairie? These are all very important questions for the future of Minnesota, and that's why I decided to get involved with this project.
We all have seen the weather on the weather stations, and we see the flow of the fronts across the land. So weather flows across the surface of the land. Well, so does climate. But climate is 30 years. We can't see it flow, yet it flows. So this project was to watch the flow of climate over time in Minnesota. So what inspired this research in the first place was to ask what is about to happen to that triple meeting point of the prairies, the broadleaf forests, and the needleleaf forests. Is it going to move east, west, north, south, what? So we realized we could study that kind of a problem and get some answers if we watch the flow of climate over the land and watch the flow of those kind of points over the land.
I've been doing research on forest disturbances and processes in forests, for example succession, when it changes from one species to another. I think these things will change a lot with a warmer climate. Climate velocity is how fast the climate is moving north. In other words, how long would it take for the climate of Minneapolis to reach Duluth? And currently it seems to be, from this analysis, about 3 miles per year that the climate is moving north in recent years. Now that's much faster than trees have historically been able to move. I mean, trees respond to climate change by moving so that they track the climate that they prefer. And when we look in the paleoecological record over the last 10,000 years, most of our tree species have moved about 1/10 of that rate, or maybe 2/10 to 3/10 of a mile per year, whereas the climate is changing at 3 miles per year. So we don't think trees will be able to keep up with the changing climate. Unfortunately, there are a lot of pests, bugs, and diseases and so on that can move very, very fast, and they'll easily be able to keep up with climate change. And there'll be more storms and more fires and so on, and those will be able to move north quite rapidly and start impacting forests.
What's different about this method is that it is very simple. It's a direct way of getting the information. It doesn't rely on lots of assumptions about how weather turns into climate. We're looking at climate by actually averaging 30 years of weather. And we see the directions things are headed, and we can, with some reasonable ideas, project it a bit further. So the simplicity and the directness from the weather, and that this can be used to complement other methods that are used. So we can get ideas of the future as it might be, but it's not the future as it shall be. With things, many different things that we're just starting to think about now, we can learn how to correct the problems that might be causing this northward trend in climate.